Hello, everyone, and thank you for choosing to attend my talk. It's about personalizing user experiences with user-based, memory-based collaborative filtering. I know it's a mouthful, but bear with me. Hopefully, by halfway through the presentation, it will all make sense. So the plan for today, I'll start with a quick introduction about myself. I'll talk about why personalization matters, and then I'll spend about half the time giving a quick overview of recommender systems, and then the other half doing a deeper dive into the memory-based, user-based, collaborative filtering. And hopefully we'll have some time for questions at the end. So a little bit about me. My name is Charles Duze. I'm a product analytics senior manager at Meta. And over the past 21 years or so, I've had the privilege of working at these six fine companies. Excuse me. My career started off as a software developer, as the data engineer. And then for the later part of my career, it's been focused on data science. So why does personalization matter? So personalization is really everywhere around us, whether we are aware of it or not. If you've used any of the products or services from any of the companies on the left, you've probably experienced the personalized, you've probably encountered a personalized experience. And the reason for this is that many companies are realizing that their users are very unique. Their taste, their preferences, their situation, everything is really specific to that user. And to be able to create the optimal experience, we have to create curated experiences for the users. Now, the one size fits all no longer works. And then being able to create like one website for every user doesn't scale. So this is where machine learning comes in. And the idea is that you can really just have one website or one app, but it's using machine learning, you can customize it, make it adaptable, and make it also perform at scale and really create these unique experiences for your users without having to 10x or nx your support. So jumping into the recommender algorithms, at the base, there are two main types of recommender algorithms. The first is the content-based filtering and the other is collaborative filtering. Content-based filtering really focuses on the relationships between the items. So if you like one item, you're very likely to also like items similar to that. This works very well in the housing scenario. So if you're trying to buy a house and you like a 3-bedroom in San Francisco, you're more likely to like another 3-bedroom in the same zip code or something close by versus a 5-bedroom in New York City. The other type is collaborative filtering, and we'll dive deeper into that. But the idea of collaborative filtering is that it takes relationships about you and people like you to help predict what would most likely be useful for you. And I'll probably save questions for the end, so I'll wait till the end of the conversation to read the comments. I'm not ignoring it, but I'll come back to it. So within collaborative filtering, there are two types of, you can break it into two types, the user-based and the item-based. The user-based collaborative filtering is really saying, first, let's identify people that are like you. And then based on what these people like that are similar to you like, we can predict or recommend things for you. So this could work in the movie scenarios, like, okay, if you find people that are similar to me and they like action movies, then I'm likely to like an action movie. The item-based collaborative filtering also uses the relationships about people, but it starts with the relationship about items based on the relationships of people. So what I mean by that is, let's say you go to a website and you buy bread, and it realizes that, okay, people who buy bread are also very likely to buy butter. So the relationship between bread and butter is not because bread and butter are the same type of items, but because people who buy bread and people who buy butter are similar, it sort of creates a similarity between those two. And so now when someone comes to your website and has bought bread, you can recommend buying butter for them too. Now, for both user-based collaborative filtering and item-based collaborative filtering, there are two approaches for implementing them. One is the memory-based approach and the other is the model-based approach. With a memory-based approach, we're taking all the information that we have and we're using statistical methods to help us make our prediction. A good example for this is the nearest neighbor type of algorithms. The model-based approach actually takes the data, doesn't use all the data at once, but it tries to learn about latent factors. So this is sort of like the train predict algorithms. and then it establishes these latent factors or these latent relationships, and it uses that to make recommendations. And one example of that is the matrix factorization, which I think was made very popular by Netflix. For this presentation, we'll focus on the memory-based, user-based collaborative filtering. So if you follow the tree, you get a sense of where we are in there. Before we jump into that, I just want to call out that in reality, when you go to any of the websites, it's not really just one algorithm or the other. In many cases, people use multiple algorithms in different types of combinations. And when they do that, we just say they have a hybrid. So jumping into our problem statement, this example comes from a previous project that I've done, but I modified it to make it a bit more generic and for a bunch of other reasons as well. So for a scenario, let's assume that we run an app store, and then users can come download apps from our stores, right? And we want to provide a personalized list of apps for each user every time they visit. A couple caveats. Users don't rate apps, so you don't have the typical app ratings that's sort of common in most textbook scenarios. It also needs to work for new users who have never visited our site or haven't had an interaction. So once again, we don't have any history of the user's interaction or behaviors with our apps. And then the other caveat that's very important is that once a user has downloaded a specific app, they no longer need similar apps to that app they've downloaded. So for example, if you download a calculator app, you don't need 2 calculator apps. You probably need maybe a paint app or something different. And this is really important because it sort of breaks a lot of the other scenarios where, okay, we can recommend movies based on movies you've already liked. The good news, though, in all these caveats is that we have some metadata about our users. So we know something about them, either from profiling their profile data or maybe interaction somewhere else in our website. But we have something that we know about the users. So this is our scenario going in. The approach we take to addressing this are 4 main steps, and we'll go into details for each of the steps in the upcoming slides. But the first is really about finding similar neighbors. The second step is scoring the apps. The third is compatibility filtering, and I'll talk about this and can happen at any stage really. And then the last and most important is the evaluation. So going into each of the steps, starting with the steps of finding similar neighbors. So in this stage or in step 1, what we really want to do is we want to find neighbors or other users that are similar to the user of interest. And so based on whatever attributes we have, so maybe we have age or we have location, we want to find users that are similar across the dimensions that we select. Now, this is simply a nearest neighbor algorithm, but there are a lot of considerations that can go into implementing this. So you want to think about, okay, of all the data that you have about the user, which ones are actually useful and which ones are really noisy. And if you choose to, even after you've narrowed down the list of features you want to use, how do you weight them? Like, is location as important as age, or is one more important than the other? And then how many neighbors do you consider? How do you weight the relationships? So a bunch of different options and decisions that you have to make. My advice here is to pick reasonable defaults for the first trip around the sun or for the first time you implement it. And then once you've implemented it, then you can come back and tune and optimize the parameters. So the second step is once you have the neighborhood of similar users, then you want to score the apps that those users have installed. Now, the way you score the apps really would be specific to your scenario. And once again, there are a bunch of options and considerations to make. You can use like a binary, or you can use a gradient. If you choose to use a gradient, you can use a discrete or continuous score, pretty much. And you can choose whether to have the votes weighted by the proximity to the user, or just have like the same weight for all users. So example here of consideration says, for example, maybe an app that is viewed by a user gets a score of 1, but an app that is installed gets a score of 5. Something of that, like, depends on the status and depends on what's important to your scenario. Once again, here, it's a good idea to start with a reasonable default and then build and just make sure everything else works and figure out everything else that you need to do for the pipeline to work. And then you can come back and fine tune and adjust the parameters. The third step, we call it compatibility filtering, but the idea here is that you want to, once you have the apps, the recommendations, you want to recommend apps that are actually compatible or relevant to the user. So for example, even if from the nearest neighbors you have a calculator app, but the user already has some type of calculator app, perhaps you don't want to recommend another calculator app for them. Or if the app you're recommending for the user is not compatible with their situation, maybe their country or their profile or whatever other information. So this is where you just have like an intelligent filters to make sure that what you recommend is also appropriate for the user. You can also put in sort of like the trustworthiness, like maybe an app with really low ratings or low value, low security, whatever the case is probably not something you want to push to the top, even if it bubbles to the top from the algorithm. So this is a way to kind of put the weight on the scales for the app. And then, like I said earlier, this filtering can actually happen at any stage in the process. And then the final step, which I think is the most important, like you can't skip this step, is really evaluating the results. And there are many different ways you can evaluate results. I like to break them down into two main groups, the offline and the online evaluation. The online evaluation is really the live test. It's like doing an A/B test, having one version versus the other, and then seeing how it behaves in real time with users and evaluating from that. Offline is really something where you do, maybe you have a copy of historical data and then you just run a simulation based on the previous interactions. Now, the online evaluation is far superior to offline. Like all the results from online always beat the offline because that's just real data. It's talking about the future, not just fitting to the past. But the challenge with online evaluation is that it's very expensive. Like you have to do it in real time. You have to wait for users. You can't like run multiple iterations in a day or in a couple hours, which you can do with offline. And so one way we try to balance that is we use the offline evaluation to help us narrow best candidates. And then when we have a smaller pool of the best candidates, then we can now go to the online evaluation and have that give us the true results. And then in terms of the evaluation itself, there are a bunch of different metrics that you can use. One of my favorites is NDCG, normalized discounted cumulative gain. And one of the reasons I like it is that it accounts for both relevance and rank. So it's saying, okay, did we recommend apps that are relevant to the user? But also, did we put them in the right order? So if we got the most relevant app and we put it in position 5, maybe it's not as good as if we had put it in position 1. But there are other very good metrics that like precision or recall at K that are also very good metrics that you can use. And there are a bunch more than these as well. Yeah, and then I think this is probably my last slide. The key thing is once you build, and this is true for many projects, once you build your pipeline, the job isn't done. You have to have this process for continuous iteration or continuous improvement. The way we tackled it is, like I said, we do the bare minimum first, and then we get everything running and we're able to stand up the algorithm. And then we now start this process of continuous iteration, which is sort of like beat the challenger, beat the winner, challenge the champion. And the idea is we have a version in production that's probably the best version we have. And then we bring up new versions that we think are good candidates or can be better. We do the live test. If the new candidates beat the current champion in performance, they become the new champion. And then we start the process again. If none of them beat it, we go back to the hypothesis. So the process we use looks something like the diagram on the left, but that's really the main idea for that. So that's a lot of content that I really covered in a short time. It's really to just give you a flavor of one intro to the algorithms and then what we did. By all means, I recommend like looking up online resources and sort of diving deeper if this is something that's of interest to you. And with that, that's my talk, that's my presentation. See if we have any questions. And I believe you can type your questions in the chat if you have them. And I'll try to look through. Okay, no questions in there. I'll stick around there and see if there are any questions that come up.
As always, it's a pleasure to have you here as part of our conference. Folks in the audience, if you have questions, please do ask them of Charles. He's got a few minutes that he can hang out. Charles, would it be okay if I end this broadcast and you take questions in the chat, which will continue to stay live?
Definitely, that works. And thanks for having me. It's a pleasure.
Absolutely. You just got a question, so we'll stay on for a second while you answer it.
Yeah. So the question is, do the offline metric require user input? So it does, but it's not live input. So essentially, the way the offline works is we sort of have the historical data. Let's say we have a user X, and we know they liked app 1, 2, and 3, or A, B, and C. And so we go in and we try to predict. And then once we predict for that user, we now say, okay, did we predict any of the ABC that the user has liked in the past? So that's the way the offline evaluation will work. The online is actually really more accurate because it's happening in real time. We're presenting it fresh from the user to the user, and then they're interacting with it. One of the challenges with offline evaluation is to be very careful that we don't have leakage, and then we're sort of like predicting stuff that we already have the answer to as part of our inputs. So hopefully that answered your question. So it does require user input, but not live user input. It's sort of like historical user input that we're taking. Great question. How do you handle drift in customer preferences in recommender systems? There are a bunch of different ways to handle this, but the big stuff is you just have to monitor stuff. So you don't once you build an algorithm, it's not this work is not done. You have to keep learning and keep evaluating. And if for some reason you see the performance or your metrics dipping, that's one good way to know that, okay, either the customer preferences have changed or the user is or the algorithm is no longer performing in the optimal state. As in user evaluation, if the user liked the recommendation or not. Yes. So it really depends on your business scenario. And one advice I always give is there is the technical evaluation, whether we use IndexCG and precision at K and all of that, or whether the user clicked. But at the end of the day, we want to ask, what's the business purpose, right? Why are we having this recommender? So if we're trying to sell apps, then we should have a metric that measures sales. So maybe just clicking on the app may not be enough, but actually looking for the actual sale to be completed would be the ideal case to do. So it's like always keep track of the business metrics, like why are we doing this in the first place, and always make sure that that's part of your evaluation. The next question is, how long does it require for training these recommendation models? That's a difficult question. It really depends, right? It depends on how big your data is, how many parameters, what algorithm you're using, and sort of like what servers or machines you have to run them. So in terms of length of time, I think it's difficult to answer. It really depends. It can be anywhere from, well, it could be a few minutes if you're just doing like a prototype on your desktop, but it could be hours, or in some cases it could be longer than a couple hours. Are the two types of recommendation algorithms you mentioned the only recommendation methodology we use? So there are actually multiple that's listed in the tree that I described. The first distinction is whether we're using like a content-based or collaborative filtering, but you have a bunch of different options. And typically we use different types of algorithms or different methodologies depending on the situation that we're trying to solve. And even in the example where I gave for the user installing apps, you can use multiple algorithms in there, like the hybrid approach. And there might be other scenarios that are more specific, where maybe the item-based or the content filtering may be more appropriate. The next question, would you say this approach solved your initial problem completely, or would you add another approach to the recommender system? It's a good question. So the answer is sort of similar to the one I just shared before, but essentially we build a base algorithm. I think recommendations isn't really something that you get to 100% in your first iteration. You have to keep tweaking, and the game continues to change. So in my experience, one algorithm or the initial approach is never enough. You either have to iterate on that specific algorithm, you may need to switch to a different algorithm, or you may need to combine algorithms together to help you get closer to the ultimate goal for your users. Besides offline tests and A/B testing, Are there any metrics you use to evaluate the effectiveness of the recommender systems? Yes, there are lots of metrics you can use. Some of the some of the additional metrics that we use that I didn't mention is actually one around coverage. So depending on the algorithm you use, you may not always have predictions for all your users. So something to evaluate is what percentage of your users that you plan to predict for do you have predictions for? And there are just a bunch of other metrics, like the list of metrics isn't like it isn't a finite list. It really depends on your scenario. What I'll just recommend is to have some kind of hierarchy or understanding of what the metrics are and how you intend to use them and why you're choosing the metrics. But there is no limit on the type of the number of metrics. Okay, and then so for the offline metric evaluation, do you split the data set into training and testing? And that sorry. So for the offline metric evaluation, do we split the data set into training and testing, as you mentioned, that we see if the user liked the recommendation using historical data? Yes, you do split the data, and it may not really be training and testing independently. Sometimes it may be time-based. So you can use information that a user had up to time X, and then you are predicting what happens after time X. So there are different ways to split the data, but the idea is in the evaluation, the data you use for evaluating has to be hidden from the training or from the build process, and only after that's built, then you want to use it for evaluation exclusively. So I think those are all the questions I have, and it looks like we're just over time. But thank you all once again, and it was my pleasure to be here. And if you have more questions, feel free to reach out to me on LinkedIn. Thank you all, and I'm gonna leave the room.